Hello everyone, welcome back to my YouTube channel. Myself Rashid. I am studying in Sri Venkateshwara College of Engineering, Bengaluru, the Department of Computer Science, Engineering and Artificial Intelligence. Today I am going to teach a topic of optical binary search trees in data structures. Let's begin the topic. Introduction. Optical binary search trees are the data structures used for efficient sharing. They provide a way to organize data in a binary tree to minimize the cost of searching. Data structures is partially useful when their searching frequency of elements varies. These are the types of you can see here: complete binary tree, full binary tree, and perfect binary trees. Binary search tree. Binary search tree are the data structures where each node has at most two children. The left child of the node consists smaller elements and the right child consists greater element. Searching in a binary search, the tree has an average time complexity of O means log n, where n is the number of elements. Cost of searching. The cost of searching in a binary tree depends on the depth of the nodes visited. The goal is to minimize the average cost of searching by arranging the tree optimals. The cost is typically measured as the number of comparison needed to find an element. You can see in the diagram. Next one is the optical binary search tree. Optical binary search tree minimize the average cost of searching by arranging the nodes optimally. The optimal is achieved by conducting the search frequencies of the elements. More frequently searching elements are placed closer to the root of the faster axis. Next one is the dynamic programming approach. The dynamic programming approach is a commonly used to construct optimal binary search tree. It breaks down the problems into a smaller subproblems and solves them efficiently. The optimal solution is a built by combination that solutions of subproblems. You can see the how to solve the dynamic programming problems by step by step. Next one is the subproblem definitions. The main subproblem is constructing optimal binary search tree as defined as follows. Choosing a route for a subtree. First we have to choose a route for a subtree and next constructing optimal binary search tree for the left and right subtrees. And next one is determining the optimal cost for a given subtree. Your second bulletin and the third bulletin. You can see the optimal binary search tree here. Next one is the computing optimal cost. The optimal cost of a subtree is computed by the considering the cost of the left and the right subtrees. It also taken into account that probabilities of accessing the elements. The cost computing is done respectively from the bottom up. Here you can see the what is the optimal price that is given as the greater profit. Next one is considering the constructing the optimal tree. Once the optimal costs are computed, the optimal binary search trees can be constructed. This is achieved by selecting the root of each subtree based on the computed cost. This process is repeated frequently until the entire tree is constructed. Here you can see the formula to construct an tree and average time, additional time, and all you can see in this diagram. Next is time complexity. Constructing binary search tree using the dynamic programming approach has a time complexity of O means n the power 3. Here n represents the number of elements in the tree. The complexity arises due to the need of the computing optimal cost for all the possible subtrees. Space complexity. The space complexity of constructing a optimal binary search tree is 0 to the that is n power 2. This is because of matrix of size n into n is used to store the component's cost. Additional arrays are used to store the probability of an unnecessary information. You can store the information using the arrays in the binary search trees. What are the advantages of optimal binary search trees? Optimal binary search trees improves searching efficiency by minimizing the cost. They are particularly effective when the search frequency of elements is very slightly simply. The dynamic programming approach ensures the optimal solution based on the given probabilities. These are the advantages of the optimal binary search trees. Next one is the limitations or disadvantages. Limitations. Constructing optimal binary search tree requires knowing the search frequency in advance. If the probability changes, the frequency of the tree may become suboptimal. The dynamic programming approach may not be suitable for a very larger data sets due to the time and the space complexibilities. These are the some limitations or disadvantages of binary search trees. Next, we come to the conclusion. Optimal binary search trees are valuable data structures for efficient searching. By arranging nodes optimal based on searching frequency, they minimize the average search cost. The dynamic programming approach allows for the considering the optimal trees efficiency. That's all from this presentation. Thank you.